So we're going to get started with Gwyn Griffiths, G3ZIL, with patterns in received noise, methods, observations, and questions.
Currently, we operate with Kiwi SDRs connected to a Linux box with a spec of a Raspberry Pi 3 or above. The Pi runs ROBs via AI6VN's Whisper daemon script to decode whisper spots and estimate the noise at the same time and on the same frequencies. Spots are reported to WhisperNet and noise estimates to our Influx time series database. While the Kiwi and the noise estimation algorithms are well characterized, this is not always so for the RF distribution system and hardly ever for the antennas in current use. Hence, at this stage, we cannot provide absolute noise levels, hence our current focus on patterns. To make noise level estimates at the same time and frequency as receiving whisper spots, we exploit gaps in time and frequency. In time, every 2 minutes, we have a 1 second gap before whisper transmissions and an 8-second gap at the end. Here's an example of transition from whisper signals to noise at KPH. We make an RMS estimate of the noise over the quietest 50 milliseconds, usually in the post-transmit window. In frequency, there are invariably gaps between whisper signals that each occupies 6 Hz. We also listen 60 Hz either side of the whisper band. We sort the FFT amplitudes and take the total power in the lowest 30% as the noise. Our noise estimates are available to all via an Influx database and a Grafana graphical web page. Here we have noise series from when ON5KQ was comparing 2 antennas on 40 meters, a beverage in green and yellow, and a long wire in cyan and orange. However, I do remind you not to trust absolute levels. Going live to Grafana, we're looking at noise levels at KPH, Point Reyes, California, on 80 meters. And now we can add in the SDR from northern Utah. We note the differences between them, especially during daytime, where northern Utah doesn't show the troughs. We can read off individual data values, and we can save as a CSV file. Moving to patterns, here on 160 meters we have noise levels from KPH and ND7M in southern Nevada. What I can do is to shift the ND7M estimates by 2.9 dB so that, on average, the nighttime values match. The plot suggests that the daytime noise level at ND7M is raised due to local noise. The daytime troughs are flat and are 9 to 15 dB higher than at KPH. This form of plot gives us a useful method for testing for local noise, given a low noise reference station even at a distance of 1,000 kilometers. To look in more detail at coherent patterns, despite uncertainty in absolute levels, we calculate the noise level anomaly. We subtract the value for a time period from a long-term average for that same time period. Here, for KPH and the northern Utah SDR, there are times of close visual correlation, such as within the orange circle, but also times of poor or inverse correlation, as in the green circle. This is not surprising, given that the daytime noise level at northern Utah was higher somewhat than at KPH. What we have here is a non-parametric density plot of correlation coefficient on the y-axis, with local time of day, which shows low and scattered correlation during the middle of the day, but consistent and high correlation values from evening through to dawn. The previous correlation plot was at zero lag. In this plot of correlation between northern Utah and ND7M, the correlation coefficient is denoted by color, and the y-axis shows a time shift from -120 to +120 minutes. Where they exist, the correlation peaks are mostly broad and centered on zero shift. Narrower peaks, as in this snapshot, do occur, and when they are matched with short period or due to short period time fluctuations seen in this plot at KPH, Northern Utah and ND7M. We also observe seasonal noise patterns. From rural Austria, this time series spans May 2019 to last week. Time of day is on the y-axis, day of year is on the x, and color shows the noise level. The black lines are at dawn and dusk. The daytime minimum in spring and summer may well be due to delayer absorption. More speculatively, the rise in daytime noise level in autumn into winter may be from thunderstorms in the southwest Pacific. A propagation forecast for November 2019, shown here, does suggest that propagation paths might exist. This is backed up by whisper spots at OE9GHV in Austria, where the November number of spots in light green in the afternoon are far more numerous than during June. As for questions, these are some of the ones we have.
Right. Thank you so much, Gwyn. Does anyone have any questions for Gwyn?
Go ahead, Carl.
Could you have Gwyn put up that last slide about the questions? It went so fast, I didn't.
For sure.
You're absolutely right. I'm just trying to bring up my PowerPoint now. It's a pity it didn't sort of freeze at that moment.
I can freeze it right there, right now. Don't worry.
Oh, can you?
I certainly can.
Okay.
Let me pop this in here and we'll go on and share that screen again. Here we go.
Oh, that's brilliant.
There we go.
Okay, good.
This is N0AX. Gwyn, are you aware of the ARRL's noise background characterization project?
We are aware of the intention to do so, and I believe one of the people involved did make contact with my colleague, Rob, AI6VN, who is also online, and perhaps, Rob, you want to take that up?
I may have to let Rob speak here.
Okay.
Yeah, hold on. I'll have to talk. Rob, you can use your microphone now.
Oh, okay. I'm here. Yes, I just had a brief conversation with, I forget who it was down in Arizona who worked on that, but I haven't been able to find a link to their project, so I don't really know what they're doing. But I'm very interested. We would love to, learn from them or collaborate in any way possible. I think that another area of questions for us is we are struggling with the volume of data we're generating, and have the influx database appears to be, although a time-optimized project or product, does seem to be overwhelmed by the whisper data and the extended whisper data that we're generating from as part of our logging process.
Rob, I think you're talking to Ned Stearns, AA7A.
Yes, that's right. Whoops, I didn't have the microphone down. I'm sorry. It wasn't probably didn't sound very good to you. Yes, I had one conversation with him, but I didn't know how to, I didn't hear back. I didn't really know how to follow up, so.
This is Phil. Ben Vitfleet also just wrote in the chat. He's PE5B. Also very interested in ARRL radio noise measurements, and he's active in the ITUR study group 3 on radio noise. Ben should be known to this audience, who gave a really nice presentation at the HamSCI workshop a couple of years ago. He's worked on NVIS and polarization and other matters. So.
And I gather, Ben, you're now based in the UK at the University of Bath?
No, I'm not anymore. I moved back to Holland in October.
Oh.
So I've been working there for 2 years, but I'm back at the radio agency of the Netherlands for part-time. And I saved the rest of the half-time as a visiting researcher at the University of Twente, sorry. And I'm still doing my old projects on NVIS, still supervising a PhD student from Bath, and looking for research funding. So that's the main things I'm working on. But in ITUR, there is not much done on radio noise, but they are revising P372. And last year we had a very strange move where a proposal from the USA tried to change the man-made noise curves to something really out of real life. We've been able to check that, to counteract that, so that's not been done, but we desperately need good, accurate, calibrated radio noise data from all over the world.
Well, I'd certainly put it's a real challenge for the calibrated. And I saw in a previous chat session ideas on perhaps moving towards a standard or a test antenna that was well characterized and available as a kit. Thankfully, I mean, through Rob's contacts and the Maritime Historical Radio Society at Point Reyes with KPH, that is an exceptionally quiet radio site, which we can say because of the daily minimum and maximum, the difference between them, and be able to measurement of those sites, I think, would be most interesting.
Yeah, and pardon me, go ahead.
Yeah, this is Jim, WA3FET. And on a related subject, a reverse beacon network and skimmers and FT8 all report basically the signal to noise ratio. And the web SDRs report the noise on like an S meter. It seems like it'd be really nice to be able to have the signal power at the receiver as well as the noise power. And then because the noise can be man-made noise, it's so variable at different locations and so forth. Just some comments why the FT8 and reverse beacon network and skimmers only report signal to noise ratio.
From our noise measurements, because they're done at the same time and at the same frequency as whisper, we have made some tests, for example, on 630 meters with a ground wave signal where the strength is very constant day and night. And by adding in the noise to signal to noise ratio, you can see that the signal is actually stable to within 1 dB.
But at HF, it would be much different, I think.
Exactly. So you could do that over 30-kilometer ground wave.
Right.
But it shows the principle is there.
Yeah, I think Gwyn, you might want to talk to AA7A. He's working with, and Ward, you might know more about this than I do, but there's the ARRL task force on collecting background noise levels, seasonal and daily. And they've just calibrated the N5IA site on the New Mexico-Arizona border. It's another very quiet site along with the Point Reyes station. And I remember Ned has checked into our weekly TeamSpeak sessions for Tangerine SDR, and he's very interested in using one of the new SDRs to do some noise measurements and noise and data collection. But he had said a few months ago that they had actually managed to calibrate the station. Now, I'm not sure what that means, but he was very excited that they had actually done calibration. So I'll be happy to put him in touch with you, and you guys can continue on from there if you're interested.
Thanks so much, Scotty, and thank you, Gwyn, as well.